What's going on, everyone? You're back with your boy Jono for another quick math lesson. Today we're going to look at how to expand and factorize a new type of quadratic called a perfect square. The mathematics behind these ones are actually not too difficult. We've seen them before. But being able to identify these ones incredibly quickly will help you out in test conditions, and it just means it might reduce your overall work. So if we have something like this, x plus 4 squared, we know we could write that out as x plus 4 bracket x plus 4. It's squared, multiplied by itself. And we could FOIL this out. That would be one way to solve this problem. We go x squared plus 4x plus 4x plus 16. Then we've got to collect our like terms, so we finish off with x squared plus 8x plus 16, and that is our final answer. But instead of foiling it out, we might look at our answer and see if there is a way that this number 4 relates to the numbers that we get in our answer. Because we've got x squared plus 8x plus 16, we can see pretty quickly that the 4 is incredibly important to both of these numbers. For the 8, it's 4 plus 4, or times by 2, and the 16 is 4 times 4. So we can see that the middle value, the 8, is just 4 times 2, and we can see the last value, the 16, is just 4 multiplied by itself, or 4 squared. So this does take us to the rule. We've got a plus b all squared, and usually that a is going to be an x value, right? The letters that we're looking at, and the b is just going to be a number. The rule is that a squared plus 2 multiplied by a multiplied by b, so 2 times the number with the letter x, plus b squared is going to give us our answer. So what this means in words is that we've got x squared plus 2 times the number with the letter x, and then multiply that number by itself, or square the last. If we look at an example really quickly, we've got x plus 7 all squared. So I know straight away without having to do much maths, I've got x squared plus 14x, which is 7 times 2 with the letter x, plus 49, which is 7 squared. That part of the rule doesn't seem very helpful. Just, yeah, I know how to use FOIL. This might save me a couple of extra seconds, but being able to turn it back or reversing the rule is where the real skills come in. This is what's going to save you quite a lot of time in a test. The big pro tip for these ones is always look out for a square number at the end. So your 1, 4, 9, 16, 25s, if you see a number like that, just think to yourself, ooh, this could be a perfect square. So if I've got x squared plus 10x plus 25, I can see straight away that the 25 is a square number, 5 squared. And then I can just double check, hey, does 5 plus 5 equal the 10? Plus to the middle times to the last? If that is true, then straight away my answer can be, ooh, I can go to x plus 5 all squared. Again, if I've got something like x squared plus 20x plus 100, I know that 100 is 10 squared. Does 10 plus 10 equal 20? Yes. So I can straight away go to the answer of x plus 10 all squared. For these ones, you do have to just be super careful of the middle value. It might take it away from being a perfect square. Something like this could be x squared plus 29x plus 100, and that's where you could go, oh, 25 and 4, that will definitely work. This is not a perfect square anymore because the middle term is not exactly, hey, it's that 10 plus 10. This is something different, just our standard factorization of our monic quadratics. So this even works if I've got a negative number. If I've got x minus 3 all squared, I've got x squared minus 6x, or 2 multiplied by that negative 3. And then this is where students sometimes make a mistake and they go, easy, negative 9. But we know that negative 3 multiplied by negative 3 is going to be positive 9. Anytime we're squaring something, we're going to end up with a positive value. So make sure that these perfect squares are always plus a constant term at the end. So this full answer is x squared minus 6x plus 9, full marks. There is like a general rule for these perfect squares. A minus b all squared is going to give us the answer of a squared minus 2ab plus b squared. But as long as we know that fundamental rule, anything squared is going to be a positive, we know that last constant term for these ones are going to be positive. So if I've got x minus 6 all squared, straight away I can go x squared minus 12x plus 36. Happy days. Anytime we're dealing with a 1, students sometimes get a little bit confused because it doesn't really look like a square number. But for this one, I've got x squared minus 2x plus 1. We need to know that negative 1 times negative 1 gives plus 1 and adds together to give that negative 2. Again, you could FOIL this out if you want to, but I guarantee this is the correct answer. So I know this topic is not actually too difficult. We've done a lot of these skills before, but this just will help us out quite a lot if we get given these in test conditions, and it's going to help us if we start needing to graph parabolas. Being able to find any type of x-intercepts quite quickly will definitely help us out. So thanks so much for watching this lesson, and I'll see you later.